this video, we're going to do a sample calculation for pooled variance. So please have your practice problems available. Follow along with me while I do two examples. I didn't put them on the practice problem sets for you this time, but get your own paper and try to calculate along with me. And then you'll have an opportunity to do practice problem number 5 on your own. So these are the pooled variance formulas that we looked at in the last video. So remember, because we have two different samples now, if we have different sample sizes, we need to use the pooled variance formula so that we can then use that pooled variance formula in our estimated standard error. For our first example, it says that we have an n of 5 for both samples. Now technically, we wouldn't have to use the pooled sample variance formula, but we're going to just to demonstrate something. So what we know is we have an SS1, sum of squared deviations for sample 1 of 36. We have our sum of squared deviations for sample 2 is 24. We know that our n is 5, so that gives us a degrees of freedom, n minus 1, 4 for both samples. So if we were just to calculate our sample variance for sample 1, would be SS is 36 over 4, which gives us 9. For sample 2, put the little notation here too, our variance would be 24 over 4, which equals 6. So now to do our pooled variance formula. Our pooled variance is going to equal SS1, which is 36, plus SS2, which is 24, over 4 plus 4, which gives us 60, right, which gives us 7.5. Which is right in the middle of the two. So if you notice, if we were to add up 9 plus 6 and divide that by 2, we're also going to get 7.5. And that's because N1 equals N2. So that's just to show you that if you had the same sample size, you wouldn't necessarily have to use the pooled sample variance formula. You could simply add up the variances and divide by 2. So note, the sample size is the same, so pooled variance is exactly halfway in between. Now, for this example, same numbers except for we have N1 is 5 and N2 is 13. So we can't use this formula. We have to use our pooled variance formula. So our SS1 is 36, and our SS2 is 24. Now, degrees of freedom for sample 1 is 5 minus 1 equals 4. Our degrees of freedom for sample 2 is 13 minus 1, which is 12. Our denominator now is 4 for degrees of freedom for sample 1 and degrees of freedom for sample 2. That's going to give us, the numerator is still 60, but now the denominator, 16, gives us a pool variance of 3.75. Notice the sample size is different, so the pool variance is closer to the variance for the larger sample. So the variance for sample 1, we said on the previous slide, was 9. The sample size stayed the same. For sample 2, we now have 24 over 12, which is 2. So that's why our 3.75 is closer to this one. And please notice that it's not in the middle like we saw for the previous one. Now it's your turn. So now have those practice problems handy. This is practice problem number 5. 1 through 4 was on the first video. So we have different sample sizes. So we have to use the pooled variance formula. So we need to know degrees of freedom for sample 1. So this is sample 1, right? Is 10 minus 1 gives us 9. Degrees of freedom for sample 2 is n minus 1. Here's our n, which is 4. So pooled variance formula. Remember, S squared is simply the variance, and the P stands for the pooled aspect of it. We take our sum of squared deviations for our sample 1, plus our sum of squared deviations for sample 2, over degrees of freedom for sample 1, which is 9, plus degrees of freedom for sample 2, which is 4. And that's going to give us 390 over 13, which gives us a pooled variance of 30. Again, sample size is different, so the variance is closer to the larger sample. So now go ahead and play the Kahoot to check your learning.